And that is about it. So let's get to the fun part now. I would like to welcome Mike Bates. He is Intel's General Manager of Energy, and Mike is going to kick things off. So Mike, thank you for being here, and over to you.
And thank you, Aaron, for being here as well. And thank you and the team from Z Prime for helping us host this this event. As you mentioned, this is actually our second annual Intel Industrial Solution Builders event. We hosted our first event last year in Paris at European Utility Week. And as we've talked to some of the folks that were there with us last year, it really seems like it's been a long year since then. And of course, we had plans to host our second event in Milan at European Utility Week, but COVID had other plans for us for that. So here we are today at this virtual event with Z Prime, and really grateful to have you here. We know there's a lot of interest in this space, and I know there's a lot of information out there, and we really appreciate you investing your time today to visit with us. So last year at our event in Paris, we announced our agreement with Iberdrola and several of our technology partners around the secondary substation platform promoter agreement. And I know we've got folks from my team and our partners are going to give us a lot more information about that later today. And you're going to hear from them on how we've advanced that secondary substation platform effort in the past year, and developing a new solution approach for modernizing the grid that is helping foster this new age of clean renewable energy. You're also going to hear from a group of pioneering utilities in the US that are working with us on a new protection and control platform for the new energy system. As well as with here some members of our team from Brussels and DC sharing their thoughts on the new policy and legislative and infrastructure initiatives that I think a lot of folks are beginning to hear about that are emerging out in support of this energy transition that is happening right now today, right under our noses, the transition away from carbon-based generation to clean renewable energy. Exciting time to be in this space. We'll also brainstorm with some industry experts on the state of the industry and what's happening, what's next, what's the future look like as it relates to grid modernization in particular, and some of the new emerging business models that we're starting to see. But again, partially the focus is going to be on what we have done with this agreement and this technology in the last year, and it has been quite a year. I think that's an understatement, and I think this has been one of the most, and probably the most unusual year that all of us have experienced. But we are starting to see the light at the end of the tunnel, and we're also starting to see what might emerge out of this COVID storm, and some of the initiatives that we saw before COVID. I think we feel like are being expedited through COVID, including what we're starting to see the pivot from some of the big oil and gas companies that are moving out of carbon-based into clean renewable energy. We think that's a driver that's moving some of the grid modernization technologies that you're going to hear about today. I think we all are also aware of a lot of the government, community and state government mandates around clean renewable energy, which is another market driver that I think we're going to see continue to increase, as well as what we're starting to hear out of Wall Street and over in Europe on the investment strategies and investment companies looking outside of risky carbon-based assets into more clean renewable energy, as well as this drive for corporate sustainability. We're hearing a lot and supporting a lot of companies looking to drive green factories. For those that are tracking this industry, you may have heard about McDonald's drive to create zero carbon stores. Again, all of these initiatives and market drivers, we believe, are moving this market and pace of change even faster, as well as the emerging new business models that we'll talk a little bit about today as well. Sustainability as a service, energy as a service, the growth of virtual power plants, or what you might call software-defined power plants. But all in all, this is a super exciting time to be in this space. I mean, who would have ever thought being in the utility space would be the IT industry? I believe that it is the IT industry, and there's just a ton of great things coming our way. And looking forward to working with all of you to work together to move this market forward. So without any further ado, let's get moving today on the program and content. I'm going to hand it off now to my colleagues, Enedis and Pritpal, who are going to give us a deep dive on the progress we've made with Iberdrola, as well as the expansion of that program to include additional utilities and technology partners. So Enedis and Pritpal, I'll hand off to you now. So thank you very much.
Thank you, Mike. Thank you very much. And good morning, good afternoon, and good evening to everybody. And we'll like to share a few slides here before we go into the discussions. So let me share my screen here. Okay. Wonderful. Here, can you see my screen?
Yes. So your screen
Okay, wonderful. Thank you. Thank you, everybody, for joining us today. We'll talk about the future of the utility market and how utility market is changing. And then also we'll share the work Intel has been doing along with Iberdrola and our ecosystem partners. And few of our ecosystem partners will join us on the panel to discuss the path forward. So here is what we'd like to share, what is going on in the power grid. So sustainability is driving the bi-directionality into the grid. So we have the penetration of renewables on both sides of the grid at large scale wind farms and solar farms at transmission level. And then we have distributed energy resources, which I call them rooftop or parking lot solar, being added at the edge of the grid. So what is happening as more and more these renewables are added to the grid, the reliability of the grid is being affected by them, because renewables are very good. They are sustainable resource of energy, but they are not reliable. They can swing up and down very quickly, but our need for the energy does not go away. And all of a sudden, once we have a lot of energy, excess energy at 1 minute, clouds come or winds die down, and then the load shifts back to the grid, and the grid has to step up. So that is the challenge which we are facing right now, and how do we deal with it? And the other thing is happening that our need for energy is going to quadruple in the coming decade. The first thing is the electrification of our transportation sector. That's on the way right now, and I think that's going to happen with the technology in the direction it is moving right now. And the second thing is the digitalization of our commerce. We will be moving more and more business online, and our data will need more data centers to process that. So keeping in mind the need for the energy is growing, and sustainability is being pushed across from many directions, and we are adding the unreliability to grid. And how do we make it more reliable going forward and maximize the utilization of renewables? So we need to rethink how do we integrate all these renewable resources into the grid with the 4 pillars. The first thing is we need to focus on automation and control modernization. And also once we build a distributed energy infrastructure, we need to secure it in a different way. And then how do we deploy applications going forward? The old way of putting a box on a truck and sending 2 people to a substation to do it, that's not scalable going forward. So the last one is that how we can get more insight into the grid, make it data driven using the federated analytics. So here is the path forward, which Intel has been working with our ecosystem partners and utilities worldwide. We build a software-defined system where we separate hardware from the software so we can accelerate the innovation and adoption of the technology. So here's the details behind it. But we go from that fixed feature function devices, which we have been building for last 50 plus years, we move towards a rugged server architecture and migrate those applications into a virtualized world or a containerized world. And what it will give us the flexibility now that we have a separated hardware from software, and we can innovate software at much faster rate versus building a custom device and going through the whole 2+ years of design, development, and certification process. What it will lead to for the utilities is that it will reduce the number of devices they have to install, maintain, and manage, in which will reduce the operation and maintenance cost for the utilities. So here is kind of, I'd like to share with you the work which Intel and our ecosystem partners working along with Iberdrola, we have been working on it. So we created this secondary substation platform group, a coalition, and we have come across all industry leaders together and start defining requirements, the vision for it, what is the kind of a ROI for utilities going to look like. An idea is to take this technology through the process of defining the specs, building a POC, going through the pilot, and then make it available to everybody. So that's the work which we are doing right now. And to my colleague, he is the secretary for this coalition group, and he's going to walk us through the rest of the process right now. I'll move to the next slide.
Thank you very much, Pritpal, and hi everyone. Greetings from Germany. So what I will present to you today right now is the vision and the strategy behind driving this change at the secondary substation level. And as my colleague Pritpal was mentioning, we formed a coalition, which is, let's say, is different than a standardization body or another organization, because this is really a working group where a lot of leading companies are joining and helping together to define the new strategy toward creating the next generation of secondary substation. This group is called Edge for Smart Secondary Substation Systems. At this moment, this group has 9 members, and you will see the names in a few minutes. And we are in advanced discussion right now to bring new members into the group. And Pritpal, could you please go to the next foil? So it's really, as Pritpal was mentioning, there are some drivers behind creation of this group, and 3 main pillars are really pushing right now the grid and the distribution system to modernize, to have a more flexible solution and being able to answer more quickly to the changes. And those 3 pillars are decarbonization, digitalization, and decentralization, because all those changes are coming with connected to the data, the data which is into the network, and also understanding the environment, so will help being more predictable and will help being more flexible in distribution of the energy. So all those 3 pillars are pushing, as I mentioned, the distribution utilities to transform. And please go to the next foil. And really, at this moment, based on the today's solution, it is quite difficult to do this transition. Why? Is really the today infrastructure, you have a lot of legacy devices, a lot of harder defined devices, and it is quite tough to update those devices or to, let's say, to retrofit or to bring something new because of the interoperability issue. Also, managing a huge ecosystem of secondary substations is quite complex when it comes to have various hardware from various vendors and really to rely and really to guarantee this interoperability of those devices. Then another issue which is blocking today this modernization of the grid is data collection and communication. So as more and more devices are deployed at the edge, more data is generated, and in the today infrastructure is quite tough to get all this data, or at least to get insight of what this data means and how to react to this data. So we need also to have a faster way to react and to take decision immediately. almost in real time. And for sure, another issue is the operational and capital expenses. By today, implementation is quite difficult, and it is related to a lot of work in the field to do any maintenance or to deploy new devices based on the new architecture. So we would love to reduce those costs associated to maintenance and also to deployment of the devices. Could you please go to the next foil? Thank you. And this group has a vision, and this vision was created really together with the utilities. So it is not coming from somebody from the outside, it is coming really from the distribution companies. And this was initially created by Iberdrola, and they really want to have a single hardware which should be used for multiple applications, which means to standardize the platform which is deployed at the secondary substation and offering a kind of IT/OT integration, an easy way to manage the devices in the field. Then also this device or this new concept should be based on standards for sure. So we are not trying to define a new standard for energy. And really interoperability of the devices is a must here, because the new concept should work also with the brownfield devices. The new concept should be also modular. So in case there is need to increase the hardware, so it will be similar to a concept coming from the data center where we are just plugging in a new module. So it is not needed to, let's say, remove anything, it is just by plugging in a module and everything will be done automatically by the underlying layout of this system. And for sure, this should be also scalable. So it should go across geography, across countries, and also fulfill all the requirements of the regulatory bodies worldwide. And for sure, security is a key aspect. So those devices deployed in the field need to be secure and to provide the highest standard of protection against the cybersecurity attacks at the both level, hardware and software. So this is the vision. So this will be the great vision how this device should look like from a distribution perspective. Pitpal, could you please go to the next foil? Thank you. And based on this vision, so this is the initial group start working on a concept really to create a new specification for the secondary substation platform. And as you can see here, you have companies from the distribution perspective, Iberdrola, you have OEM, ODMs working in this group, like Circutor, ZIV, Landis+Gyr, Meritronic. Then you have also some vendor and integrators like software vendor and integrators like Nebbiolo, Ariadna, or Indra by the group Minstate. So a lot of companies are coming here together, and for sure Intel from a hardware perspective. This is a very, let's say, homogeneous group, and we start collaborating together really from all the aspects, as I mentioned, from the hardware up to the software to the application layer to fulfill all the requirements coming from the Iberdrola. As I mentioned, very soon we will do some announcement of the expansion of this group. We are in, let's say, the final steps right now for announcing this this expansion. Could you please go to the next foil, Pitpal? Thank you very much. So this is the scope of this group. First of all, we need to validate that the architecture, the business case, the revenue models, and the specification of this new concept for the secondary substation are really fulfilling all the requirements of the market. And from a timeline perspective, very quick to mention here, we are right now, we started already the proof of concept. So we are testing, some of the aspects of this new concept, and we are targeting to have the field test with a device which is certified at the end of 2021. So from the entire architecture, what this group is targeting is really to validate the entire system, from the hardware up to the application and the entire flow of and life cycle of the application. So this is something we are trying to address, to specify and also to validate. Next foil, please. And a very high-level architecture overview of this new concept is not something new. We are not reinventing the wheel. It's just that the technology is allowing right now to move also toward energy market. Maybe many of you will recognize here a concept which is coming from the telecommunication side, where the hardware underlying to the software is really standardized. And then you have, through an hypervisor, the possibility to launch various virtual environments where the applications are running. And to make an analogy with the today implementation, where you have a lot of hardware which is doing a specific functions, so those kind of hardware functions will be taken by a virtual application running in a virtual environment. For sure, you will still have some physical I/O for the information coming from the sensors, but most of the work will be moving from the hardware world to the software world. And definitively orchestration, monitoring, and security are playing a key role in this architecture. And this is at this moment what we are testing during the POC stage, is really how all these physical function is behaving into the new virtual environment. Next foil, please. And the last foil here, I want to present to you the high-level block diagram and the use cases we are targeting to touch with this new platform. As you can see on the left side, so it is really the full system depicted here. You know, on the lower side of the picture, you will have the hardware platform and the concept of the virtualization. And what you will see on the upper part of the image is really all the life cycle of the development of the application, certifying the application, having it into a storage, you know, and being able to deploy it. And for sure, you know, the entire environment should be a secure one, so that nobody would have any access, you know, to hijack the network. And for sure, also, what are the new revenue streams? You know, so this is also a big aspect of the working group. You know, so what kind of business we can generate by this? It is not that we are replacing one technology with another, so we need also to think what kind of new services we can build on top. And for sure, for the beginning, right now, we selected a list of use cases we want to deploy on top of this platform, as you can see on the right side. From a data concentrator, advanced low voltage supervisor, grid topology identification, outage prediction. So all those kind of functionality is already there, implemented into the field today in a physical device. So we are trying to bring those information together, and based on the data generated by all those use cases, you know, so really to create a new intelligent secondary substation, which will react and will respond, you know, to the new challenges on the market, as my colleague Prithpal was mentioning. With this one, I think we are done with this presentation. Definitely, if you have any questions, you have my email already. It was shown at the beginning of the presentation. You can drop me an email. I will be more than happy to discuss with you on this one. Prithpal, with this one, I would love to return it back to you and to start with the panel discussion, where we have invited two of our strategic partners in this group. We have Aitor Amezoa from ZIV and Harit Zubia from Meritronic, representing also Ariadna, and they will help us to go through some real world and really the strategy behind this movement toward the intelligent secondary substation. Prithpal,
yeah, so you know, thank you very much, and welcoming Harit and Aitor to join the panel here. So to open the discussion, I think it would be a good idea, Harit and Aitor, if you can introduce yourself and share a couple of your thoughts on the modernization in the grid sector. Harit, can you go first, please?
Yep. Yes. Hello everybody. This is Harit Zubia. I'm the technical manager of Ariadna, and as Jonut said, I also represent Meritronic. In Ariadna, we do the software, the simulation things of the electric network, detecting cables, knowing where the cables go through. We used to do that with devices, electronics. Now we have moved to software to do all these sort of things by algorithms. And in Meditronic, what we do is we have all the electronics that are starting to appear on the secondary substations, because usually there was no metering at the secondary substation, but now they are starting to deploy massively on this. So we have all this vision of electronics and processing of the information.
Thank you, Harit. Tur, you'd like to introduce yourself, please?
Yeah, sure. Can you see me?
Yes,
Yeah,
we can see you and we can hear you, Aitor.
Okay. So my name is Aitor Amezua. I'm the business development manager for CIV. And we are a company which manufactures protection and control devices, smart meters and communication stuff for substations, starting from extra high voltages. This is from transmission networks down to the users' facilities, user premises, and very low voltages. So we manufacture is hardware. We develop this the firmware that goes inside our devices, and also, of course, the applications that we need to manage all these devices that we are deploying all around the world in most of the utilities that have transmission and distribution networks.
Thank you, Aitor, and thank you, gentlemen. So I'd like to kick off some discussion here. I'd like to hear Harit's few of your thoughts on the bi-directional grid and challenges associated with it. So what you have seen working with the utilities around the world, and your thoughts on it, how we can manage it going forward.
Mm-hmm. Okay, so the challenges that are appearing here, because we all know the passive low voltage network where power flows from generation to the consumer one way. But now that many consumers are starting to have renewable at home, this is good for the consumer, this is good for the system, but for the distribution company, this is a kind of headache, because especially when these solar systems are connected in a single phase, of course, to inject energy on the network, what it does is it raises the voltage of the network, right? So this can create problems of over voltages on certain areas. Remember that electricity grids have been passive until now. So now there's some guy here injecting voltage on, for example, one phase. So this is a problem for the electric utility company, but because until now they can't do anything, okay? Another thing can be EVs. EVs are not they are not distributed energy resources until they will inject energy, but they will start consuming. And the bad thing is that for the distribution company is that prices drop at the same time. So everybody will charge the car at home at the same moment. So this will rise to peaks in power demand that can create congestion points in the network, okay? So this is another problem that it is starting to appear and will be harder for the future, okay? Okay, now passive networks, new problems, but we have all this digitization, which is really great. And don't forget, there are millions of smart meters on the field measuring energy and that can be treated as sensors also. And because there are starting to appear sensors at the secondary substation part, we have many sensors at the final spot of the grid and also at the starting part of the low voltage grid. So combining this information is really interesting to tackle all these problems, okay? Okay, as you said, now we have pieces of hardware on the secondary substation that can do certain things, but they're not being thought to be able to be programmable to address all these type of new use cases, okay? So the intelligence is starting to go to the server, okay? In the server, you can program many things, many use cases, but as Jon said earlier, and you also said, this will start to be, start to work on the moment, okay? And the communication networks from secondary substation to servers are not fiber optics everywhere. No, there
Yeah.
may be 10% of networks can be fiber optics. In many places, we have latencies in communications. We have GPRS communications, for example. We have all digital radios.
So Harit, if I try to say, so you are thinking it is not possible to take all the data from the secondary substation to a data center to process it because there's a lot of communication issues.
That's right.
Okay, got it.
That's right. You can't deploy all this new intelligence that we are starting to manage all from the server, okay? Because as I said, maybe 90% of 80% of secondary substations are not, they don't have good communication. So what do we have to do? We need to bring all this intelligence to the edge of the network. This is to the secondary substation. Okay, this is what we are working on. Okay.
Thank you very much. Heitor, do you like to add some thoughts to it?
Yeah, basically, I agree with Aritz's point of view. I would say that in a different way. So I wanted to tell you a story. Actually, I wanted to tell you a joke, but I'm so bad telling jokes in Spanish that I would not even try that in English. So the story starts in 1993, where the company which I worked for was founded. At that time, the analog electronics was the typical electronic that was being used everywhere in the utilities. But digital electronics started there. So the company was founded with one goal, one clear decision made by the founders, which was use strictly digital technologies for that. So at that time, we started with the, manufacturing devices based on digital technology. So we created the foundations of the transition from the analog electronics to digital electronics. What was the point there? The point there was the main difference was getting data out of the devices from the field that was not even available before, because the relays were acting locally, and no data was stored anywhere. So that was a real change at that point in time. Those were relays and devices and protection and control devices that were not connected to the world. There were standalone devices. After that, we have seen the explosion of internet, interconnected facilities, so data going back and forth everywhere. So that has brought us to an era where we are witnessing a new step down the path of the digitalization, which is being able to process that data that was before in the field, and now we can process that data up in the utility systems. So the data, which is called to be the crude oil of today, we are able to process that and get information out of that data. And this is really interesting. So we have facilities in the field that create data, and then we process that to have information. The trend today, as Aritz was pointing out, is that the trend is try to process that data closer from the origin, closer from the source, and avoid transmitting those the big amounts of data from the field down up to the systems because of the different kind of communications media that we have there. And so it's much more interesting for DSO, for an operator, to have information rather than data. So if we process the data locally, we give them information, we are helping them to make faster and wiser decisions.
Yes.
So I would say that we are going from data-driven utilities to information-driven utilities. Mm-hmm. So,
thank you. Yes.
Yeah, basically, I was going to say that the raw data means little to an operator. They need information. So if we make a comparison with a library, that would be like having a library full of words instead of books. And we read books. DSOs need information.
Yes.
That's where we need to give to
That's
them.
right.
So thank you very much, Artur. And I'd like to basically jump into another idea, is that as both of you are saying that the data is the key going forward, and utilities need to extract that intelligence, that information from the data, so to get a better visibility and drive the optimization in their networks. So Harriet, coming back to you, how you think this information can be used, the data which we are going to collect at the edge, to create a kind of a digital twin of the utility network, okay? And so that utilities can predict, forecast, can go back and forth and understand it, what has happened in their network, what is happening right now, and what's going to happen in future. How all that this data can be used, and I'd like to hear your thoughts on it.
Okay. By the way, Ariadna, the name of the company, is because of the Greek goddess that helped Teseo get out of the maze, of the labyrinth. In this case, our labyrinth or our maze is the electric network. Okay, so knowing how the network is composed, knowing exactly which cable goes to which customer through which street, is not 100% reliable on all the databases of electric utilities. So there is a need for collecting all this data, the data from smart meters, the data from secondary substations, and combining this data. There is a need to find this structure, this physical asset model, okay, of the network. This is what we are doing now in Ariadna. This is one part. Knowing reliably what the network is down there is one thing, and then applying all the measurements of smart meters, all the measurements of secondary substations, we can simulate and know the dynamics of its operation, okay? Dynamics, what happened 1 month ago, what happened yesterday, but also we can focus what can happen tomorrow, 1 hour from here, or next month. This is key to do anything on a network, because if some EV charger wants to have 8 kilowatt, we need to see if the network can handle this, but also we need to know this network, if usually it can handle this in 2 hours or 3 hours or 4 hours. Okay, so we need to have this digital twin, as I say, the physical and the dynamics to do things. Okay, so all this comes to the flexibility of the market that will come on the future. Okay, so as I say, EV charging, changing thermostats, for example, managing all this, or managing even, if it's possible, renewable injection could be another thing, because if somebody's injecting too much power on one phase, we could say, okay, please slow down a little bit. If it's possible, through regulation to do this, but this will come on the future. Not so
Thank
close.
you. So I can continue this discussion with Artur. Artur, what do you think about the digitalization of substation is going to drive the grid modernization, as you said, from the data to the information? Okay. How you see from your perspective that's going to happen going forward, and the utilities will get more value out of this modernization?
As I said before, utilities are improving their effectiveness and their performance, because they are getting much more valuable information out from the field. So they can focus more on their core business, which is really managing the assets that they have in the field, rather than focusing on managing the data themselves. So if we somehow are able to provide process data to them, they can focus on their business, which is, as I said, basically managing the assets that they have in the field. So that brings us, the model that we are witnessing today is a bit different and that is, we are in a point in which we need to rethink how we are doing businesses, both technology providers and utilities, and also the regulator, because this is going to be a huge change in the way the business was done before.
That's
Yeah, so I think it goes back to I remember like a few years back when we initially started discussing, we had discussion when I started discussing this idea with you, and I still remember what did you say? He says, yes, it is going to be a disruptive to my business, but if I don't change, somebody else will disrupt my business. So in that context, when you see that where we are separating hardware and software, okay, where basically you have a standardized hardware, but there will be a lot of push towards the software technologies to drive the basically acceleration of the and adoption of new technology in the utility industry. So what do you see that migration for your business and also about the ecosystem to help utilities? So I'd like to hear your thoughts on it.
If we pick up the story of the journey that we started in 1993, so we crawled, we learned working, we ran, we have some accidents, and now we are quite grown-up people. So it's 27 years now from that date where we started, and it's time to leave our parents' house, found our own family, and have children. So we're panicking. That's the point where we are. So we created an ecosystem that has set up the scene for the creation of the new technology providers, new startups, new startup companies, new commerce that are going to have a lot of data and a lot of things to tell in the future. So we unconsciously or consciously, I don't know how it really happened, have been evolving the technology, and now we are in a scenario where we are providing data not only for the information, not only to our utilities, also for the rest of the world, and authorities and are also promoting that this information should be used to benefit the final consumer. And this is this is opening the scene to newcomers and to startups that are able to manage that information in a different way to provide new services and new products to the market. So this is definitely disruptive for us, but it is the way it is. So we cannot go against that. So we need to readapt our business model and adapt that to the new circumstances. What it is true is that this is an industry that even though has been going through unbundling the processes and deregulation processes all around the world, DSOs and DNOs and TSOs or ISOs are still regulated in most of the places. And this means that the regulator has a lot to say in this business, and the regulation and regulators must also adapt their schemes or the way they incentivize the investments and in the networks to be able to adapt that to the new business models that are going to be present in a few years, I believe.
Yes. So I think thank you very much, Atur. Thank you, Harit, for joining. Thank you very much for your support. So just like a final thoughts from my side, that basically by digitalizing the substations, we will have these applications residing on a single platform in a distributed fashion, going to provide a very high reliability, but we can take the data from various sources, as Harit mentioned earlier, the smart meters and the devices in the substation, when all the data can be combined together in better term in a single database, then we can apply the next generation machine learning, deep learning technologies to extract that intelligence, the information, and give utilities insights what is happening. So it will benefit, I think, utilities also, number one, to meet their sustainability goals, to maximize or optimize the use of renewables, also manage the load, do active grid management, actively manage when there are too much renewables, when the load is going to shift to the grid, improve the reliability, and also at the same time reduce the operation and maintenance cost. And what it will lead to is going to lead to the new business models for the lot of companies. First, the utilities, how they're going to buy products and services going forward. And also on the various businesses, there will be software and services business. And what I can see that return to investment will be much faster than the traditional model, which we have been using for a long time. So thank you very much for joining. And if anybody had a question, please send us the emails. We'll happy to answer to your questions and connect with you. Thank you.